9, are you? Okay. All right. All right, guys, we are going to go ahead and get started. Something that you're going to need to do every day is sign in. If you have read through everything, which I'm hoping you have, then you know that we are going to be keeping up with attendance. Out of curiosity, how many days can you miss and still keep the grade that you earn? 4. That's correct. After that, you actually start to do what? Drop a letter grade or more. So good. What I want you to do, and I realize this is small print, but I wanted to keep it as concise as possible. So what I want you to do is put your initials in the blank. I have written a note at the top of the first page, and it says use a pencil or black or dark blue pen, because I'm going to be writing in it in green or red. So try to use something that doesn't stand out, because I want what I write to stand out. Please initial it and make sure that you receive that every day. It is your responsibility to make sure that you receive that. For instance, if it misses a whole row, that's your fault, not mine. That's going to be calling you absent. So you watch it, and if you haven't seen it during a class period, I'll put it back up here when we finish with it, so send it back down when you finish in the back, and I'm going to leave it here. Make sure you sign in every day, okay? That's very important for your grade, so make sure that you sign in. Do I have any questions before we really get started? Do I have any questions over the video? Are there any questions over the class being videoed? Okay. All right, then let's grab your notes, and we're going to get going. I do have one announcement regarding the tutoring sessions that I want to talk about. I tell you what, to make things easier so that we don't forget this, go ahead and take that form. Don't fold it up. Go ahead and take it and pass it to this side of the room, please. Pass it to that side of the room, and he can pick those up. If you haven't had time to sign it, or if you have questions, then just hold on to it, and we can take care of it at the end of class. All right, couple of comments I want to make before we start on today's notes. In regards to the syllabus, I talked a little bit about past sessions and the opportunity for you to get extra credit for tutoring. Go ahead and fill this out if you can, and then hand it to him or put it up here when you leave. PASS is going to be held. I've got the new times. Now, I just emailed this to you this afternoon, so it's online. You don't have to, I'm not going to write it down. I've already written it down online. But let me just go ahead and tell you and introduce Dakota to you. The PASS sessions will be held on Monday from 3:30 to 4:30. That's right before this class. I realize that. You've got time to get up the hill from Downing Student Union. 3:30 to 4:30 on Monday. Tuesday and Thursday, they are going to be held from approximately 6:15 until 7. When I say approximately 6:15, I'm going to explain that for a little bit. Because of Dakota's schedule, some days he may be able to be there at 6. Some days he may not be there until 6:20. If you want to think, well, if I get there early, I'll have more time, so I'm going to go ahead and get there at 6 and hope he's there, that's great. Don't give up on him, though, if he's not there until 6:20. The plan is to be there about 6:15 on Tuesday and Thursday. We want you to come and get the help that you want, but we are trying to do it based on his schedule and your schedule, because I wanted it to be an opportunity that everyone had, not during their class time. And this was the best fit that we could come up with. So this is Dakota. This is Dakota. He is going to be here on Wednesday evening, every Wednesday evening. He is here on Monday in Monday morning's class. So you won't see him on Monday morning. Am I right on this? So he's here on Monday morning in the 8 o'clock class. So you guys won't see him on Monday, but you'll see him on Wednesday. Why and what is PASS? PASS stands for Peer Assisted Study Sessions. And basically what that boils down to is we are offering you extra help. We have the opportunity for the university, the Learning Center is actually paying Dakota to sit in this class again. He had the class in the spring. He's sitting in the class again, taking notes as if he were a student. Then he is going to hold study sessions with you guys free of charge. Because he has had me before and because he is sitting in here now with you all, it's a great opportunity for you to get help because he knows what I do in my classroom. He knows how I teach. And so it's kind of like having a mini teacher. He can be the mini me when I'm not there for you. He can help you. And so you've got 3 opportunities a week to meet with him. This starts Monday. Starts Monday. PASS starts on Monday. So you have the opportunity starting on Monday to get the help that you need. Any questions on PASS? It's in Downing Student Union 2141, I think that's what I put on the syllabus, maybe 2114. It's on Blackboard though too. I put it this morning. So are there any questions on PASS? You all look scared. Are you scared? Don't be scared. Don't be scared. You've already seen me. You saw funny things. Do you know how hard that is? I had 5 students that night, or that afternoon. I think it was a week ago that I did that. May have been Tuesday. I think it may have been last Tuesday. I can't remember if it's last Tuesday or last Wednesday. Do you remember? Last Tuesday. So it's kind of funny. Let me make a comment about the video. I hope you watched the video. If you haven't watched the video, you better watch the video because there will be a test question that you won't know the answer to unless you watch the video. So you need to watch the video. If you chose not to and just said, I don't care, I'm not going to watch that, I would if I were you, okay? Couple things I want to point out regarding the video. There is a survey already on Media's site, I believe, or actually it's probably on Blackboard. I didn't go to it to see it. But there is a video, or there's a survey rather, already about that video. They need some feedback to know. The man that was here just a few minutes ago that took the forms, he is one of the developers of this program for the video series. And he is trying to get feedback to know how it's working for you guys. I know for me personally, when I watched that video, there was some lag time. The talking and the screen up here was right on target. But the things I wrote were off compared to what the screen showed. Some of you may have had the same delay. I think it was an internet connection. I know for me personally, I feel confident it was an internet connection. He was telling me today that another guy was able to replicate that, and by slowing his internet down, he could replicate that. So we do think it's an internet issue. If you had that problem and it was super annoying, I would try to go where you have better internet to watch the video if you need to watch the video. Question students may have is, do I have to watch the videos? No, you don't have to watch the videos. They're for you to learn from if you need the help. Now, the first video you had to watch because we missed class. Why did I do that? Because this is a 4-hour class that meets twice a week. If we had not had that whole lecture, we would have been way behind already starting the semester, and I didn't want that to happen. So I chose to do that ahead of time, allowing you to kind of get started. And the great thing is I've looked on Sapling on the grade sheet, and it looks like a lot of you have already started Sapling. Even if you haven't started, you've at least registered, and that's great. You all are showing initiative, and I appreciate that. Good job on that. Now, some of you, I will say, though, you need to consider not taking this class if you have not had the math background. I have done some checks of math that some of you are in. I have not checked every one of you. But there are some folks who are in Chemistry 109 who are only in, right now, Math 055 or Math 096. Do not take chemistry until you get through all the way through those pre-math courses, and you need to be in at least 109 math or above. Does that make sense? So if you have a question, ask me. Again, I sent this out again today. I'd already sent it out more than once, and I sent it again. Some of you need to talk to me. The other thing I've done is I've looked at your majors. Some of you are not nursing majors. Some of you evidently haven't read my emails. You need to go back and find all your emails. College can be overwhelming. I mean, you guys are like the technological savvy generation, but for many of you, your net ID and your WKU email and all that stuff is kind of overwhelming at times, and you've just kind of like said, okay, whatever, I'm here, I'm not going to worry about it. Chances are you need to do a little more concerning about those things, because I've sent lots of announcements. If you haven't received emails from me, then you are not checking the right email account. So double check that, okay? Ask me if you have questions. Any questions right now before we get started? You should have day 1 notes as well as day 2 notes. Go ahead and grab those and grab a calculator. Can you guys in the back see this okay? All right, we stopped with this hanging, and I said that we would learn how to do scientific notation. If you didn't remember, we would learn how to do it today. So this is what we're going to be doing. I want to just give you a big picture for today and most of next week. We're going to spend a lot of time on math. We're going to spend a lot of time on measuring and understanding the numbers of math. Now, has anyone in here had the nursing calculations class? Okay. For what we are going to do, it may seem a little backwards. Most people, though, will say that this way is easier. For the rest of you, which is the majority of you, learn my method of solving problems, and when you get to that nursing calculations class, it's going to be a breeze. And that's what I hear. So pay attention to what we're doing for the next, pay attention always, but especially for the next few days. Really pay attention to the math part of this, and it will make things a lot easier. Now, some of you, one of the things that's going to frustrate a few of you, some of you have had 2 years of high school chemistry, or you had a really, really good high school chemistry background. Some of you are in this class and you've never had a high school chemistry class. And so I'm speaking right now to this huge array of people. There are some of you that scientific notation, the fact that I'm teaching that, you are probably saying, man, what does she think? We're stupid? Then there are others of you that say, I have no idea what she's talking about. You've got to remember this is where I'm teaching. So give grace to everybody and realize I have to teach to both. We're going to get all caught up and we're going to be together. But realize today, when it seems like I'm teaching you things like rounding that everybody should know how to do, there's a reason that I'm doing it, okay? So just bear with us as we go through this. Scientific notation is writing numbers as a power of 10. And what I want to stress is that we are going to only have one digit. 1, 2, 3, 4, 5, 6, 7, 8, or 9 may be in front of the decimal. For instance, you cannot have a proper number in scientific notation that's like 23.5 times 10 to the 4th. It would be 2.35 times 10 to the 5th. Okay? So you can only have one digit. The point is 23 in front is not right, but 2 is. Does that make sense? How do we know if it's a positive exponent or a negative exponent? If it's less than 1, you're going to move the decimal to the right and the power is negative. If it is greater than 1, move the decimal to the left and the power is positive. Real simple way to remember this. Little numbers have negative exponents. Big numbers have what? Positive exponents. All right, I haven't told you this, but you have to talk to me, okay? This is an interactive class. It gets really boring to teach to nobody, all right? So you've got to talk to me. I know if you understand things when you talk to me. If you just sit there chewing your nails, I don't have a clue what you're thinking. But if you're talking to me, I have an idea. So you've got to talk to me. You've got to be here. Some of you are zoned out back in the back row. I'm going to move y'all all up front if you keep looking like you're off in space. Be with me, okay? You've got to be with me, please. All right, so let's look at these. Put into or take out of scientific notation. 0.342. 0.342, big or small number? Small number. So what do? We move the decimal to the right one place, and it becomes 3.42 times 10 to the negative 1 grams. Yes or no? Why is it negative? Because it's a small number. It's less than 1. All right, tell me, is 8.08 times 10 to the negative 2, is that a big or small number? Small number. Why do I say it's a small number? Negative. It's a small number because it's negative. You just get that in your head. Negative is small number. Negative is a small number. That means I'm going to go out of 1, 2 to make it small. We put a 0 in front, 0.808 grams. Yes or no? Now the question is this 0 important? Do I have to put that 0? I don't have to put it. Is it a good idea to put it? Why? So that we know there is a decimal rather than just a stray mark. Definitely. Put it. It's not significant, though, and it's not important, but it's nice to have it. Now, let's talk about significant digits for a minute. That was what the video was about. How many significant digits does this have? 3. Do we still maintain 3? Yes. How many does this have? 3. Do we still have 3? Yes, because are these two zeros significant? No, those are not significant. All right, let's go to the next one. 2.80 times 10 to the third grams. Big or little number? Big. So what do? 2, 8, keep going. Now then, the question is, do I put a decimal or do I not put a decimal? I don't put a decimal. How many significant digits are here? 3. That 0 is significant at the end. So that has 3 significant digits. Now, the way I wrote this, how many does it have? 2. If I put a decimal at the end, how many would it have? 4. Now, one of the questions that some people always ask is, how do I know when I have to use scientific notation? And my answer is, you will know because you have to use scientific notation in order to get the right number of significant figures. So if this answer had to have 3 significant figures, then how would you have to write it? Say it. Scientific notation. Because here it shows 2 significant figures. If I put a decimal, it would be 4. That's how you'll know to use scientific notation. And we'll see this again. So realize this is 3 significant figures. This is 2. This is a scenario where you cannot duplicate the significant figures out of scientific notation. Big or small number? Small number. What's my answer? Some of you did it right. Some of you didn't do it right. It's 9.800 times 10 to the negative 1. Why do I have to put those zeros? Maybe Thank you for the right amount of significant figures. That's exactly right. How many significant figures does this number have? 4. Sounds like you guys haven't watched the video. These zeros are significant. Okay? These zeros are significant. Are they significant here the way I've drawn it? Yes. What if I didn't put them? Then how many significant figures would that be? 2. Go ahead.
Wait, I thought trailing zeros weren't significant.
Zeros at the end of a number that includes a decimal are significant. If the number includes a decimal and the zeros are at the end, they are significant. So both places, they are significant. But if we don't put them, then it would just be 2 significant digits. Now, the question that some of you have here is, well, why would you even put this in scientific notation to begin with? I wouldn't. I probably wouldn't put that in scientific notation. This shows 4 significant digits very nicely. This also shows 4 significant figures, but am I having to write more here? Yes. Go ahead.
So on the third one, the reason that you didn't put a decimal at the end of the number is because it originally didn't have a decimal?
No, it's because it originally has 3 significant digits. This is truly not exactly the same. These two are not the same. Number-wise, they are the same. Significant figures are wrong. So put a note if that's confusing. Put sig figs don't agree. These, the significant figures, do not agree. There's no way to make this in decimal notation with 3 significant digits. But all the rest of these you can. So here, this has 4 significant digits. We have to keep it 4 significant digits. Typically speaking, converting from scientific notation into and out of does not change significant figures. It shouldn't. If it does, then that means you had to leave it in scientific notation, which is what this is showing us. Okay? How many does this have? 4. Why? Because the decimal is at the end of the number, and that says those zeros are significant. So tell me now, how do I write this? 3.700 times 10 to the what? 3rd grams. Do I have to leave those zeros? Yes, because they're significant here, they're significant here. Does that change the number? No, it's the same number. I wish I'd looked to see how many of you had watched the video. Okay, and that's good. If you're still confused on that topic, go back and there's a second video that's shorter. That's just me doing a worksheet. And practice again, and I think that'll help, okay? It'll take some time, and we're going to practice it. We're going to do it a lot. So this is something that you're going to see the rest of the semester. Tell me about this number. How many significant figures are here to begin with? 3. Good job. These 3, because these are not significant. So how do I put this in scientific notation to maintain the 3 significant digits? 10 to the what? Good. Good. All right. You're confused, but it's interesting. You got that one right. They're no different. Look. Is there a decimal? Is there a decimal? Is there a decimal? Are all of these zeros that we're calling significant at the end of a number that includes a decimal? Which means they are significant. That's the rule. That's the rule. But the zeros in front, what? Are not significant. That's your rule. All right, run through these real quick and do them, and then I'll let you give me the answers. Did everyone see the sign-in sheet? When you all see it coming by you, holler, okay? Okay, what did you get for this first one? How do I write it? 2.23 times 10 to the grams. Good. Anybody question that? Go ahead. Even though there is no decimal written, we realize the magnitude of this number is in millions. So we say this is where the decimal is understood to be 1, 2, 3, 4, 5, 6, 7. Okay? Give me the digits for this. You don't have to tell me 1,000 or whatever. Just give me 6 grams. Good. Tell me about this number. Is it big or small? Good. Tell me how to write it. 0. Good. Good. Why do I write this 0 at the end? Because it is significant. Are these zeros significant? No. Good. Is this making sense more? All right. Grab your calculator and let's talk about how to use it. Folks, you cannot, you may not, you will not be allowed to use a graphing calculator on your test. Today, if you only have a graphing calculator, that's fine. If you only have a cell phone, it's not fine. Put it up. But for your exams, you can only use a non-programmable calculator. If you had to buy another one for your other classes, I'm sorry, you still have to have a non-programmable calculator for this class. If financial problems are a problem, if finances are a problem, ask me and we'll work something out. But you may not use a graphing calculator for the exam. So just realize that up front, that you may not use one. The two that I suggested, it looks like most of you have those, and that's good. They're easy to use. Let me show you how to use these. Find on your calculator the EE key. If you've got the TI-30XA, it's right here above the 7. If you have the TI-30X2S, it's above the 7, but it's a second function. If you have the graphing calculator, I believe it is a second function on there as well. So what do we do to put into scientific notation? The EE key, this is all explained right here. The EE key means times 10, which means you are not going to put in 10. You're going to hit EE, and that means times 10. Then you will put in your exponent. So let's write in this. 3.48 EE 4 times 6.24 EE, then hit your negative key, not your minus, but the negative positive key, 3 equals. It's all written out there what to write in, what to type in. So you get 217.152. If you did not get that, tell me. You may not get it? Are you trying to use parentheses? Okay, good. Clear it all out and let's do it again. Which calculator do you have? 2S? Okay, I'll do it with you. So this is the same calculator you have. 3.48 second EE 4. Let me try to get the glare. It's not working. There we go. Do you have that on your calculator? Is that what it looks like? Same thing? You don't hit EE twice. That's probably what you did. You just hit it once, but it is the EE key. Okay? Times 6.24 second EE negative 3. But you did hit it once.
Yes. I probably just putting it in wrong.
Clear it all out. Anybody else having trouble? Which one do you have? 30XA? Keep trying yours. Let's clear it all out. You got everything clear? Turn it off and on. Make sure everything's out of it. Now then, do you see your EE key right here? So you're going to go 3.48 EE, just hit it once, 4. Is that what it looks like? Times 6.24, hit the EE key again, then hit this bottom negative key down there, 3 equals. Okay? Everybody get it?
I got it, but how come you can't use parentheses?
You can, but it's a waste of time, and you don't need to, and I've seen it cause more problems than help. I wouldn't get in the habit of doing it, okay? Your calculator knows how to work, and so let it work without using the parentheses, because multiplication is always going to be done first on these calculators, okay?
If you have the TI-30XS, it's like...
That is a totally different beast. It can be done on there. That's not the one that I like. You have to kind of figure it out.
Yeah, because like it's .ee, it's like a 10, like X.
And it's totally weird, yeah. You have to figure it out, and it's a totally different thing. That's why I recommend just those two, because it's the same way on both of those. Okay? I think you might have had that for a math class maybe. Yeah. And that's the unfortunate thing. I don't know why we can't all get together on our calculators. It'd be nice. So, all right. Plug in the or we're going to deal with this final answer. This is not the final answer, but the rest of this whole page here, there's like not one thing that I can teach before the other, so we're going to talk about all of it. Plug this one in, though. Plug the next problem in. Just get that in on your calculator. What do you get on your calculator? Come on, what did you get?
1.027. Yeah.
You're on the right track. Now keep going. Times 10 to the 10th. Did everyone get times 10 to the 10th? Let me also tell you something that is, in a sense, a new problem. Some of you, and I don't see all of you doing this tonight, which is kind of unusual, but some of you are. Some of you are holding your phone like this because you're used to these double thumbs going to town. You cannot text on a calculator. If you try to double finger it, you're going to mess up, okay? So one finger on a calculator will work much better. So do not think your calculator can think as fast as your phone. It can't. So don't do that. That's where some of the trouble comes. Sounds like you guys are getting this, though. Okay? Now, what I want us to do before we put final answers here, we have to actually look at the function of what we did, which is multiplication or division. And there are rules that apply to that when we're dealing with significant figures. Now, I will say at this point, I have taken units off to make it simpler for us, just to be faster. So there are no units here, but realize that everything we are dealing with are measured numbers, or we wouldn't be talking about significant figures. So let's come down to this rule at the bottom. How do I use significant figures in calculations? And the multiplication and division rule says the answer must contain the same number of significant figures as in the measurement with the least number of significant figures. So we have to count. We're counting significant figures. That's what we're doing here. Count the number of significant figures. How many significant figures does 4.55 have? 3. 2.8. 6.455. 4. That means my final answer should have how many? 2. All right. We're going to do the same thing for all 4 of these, but before we do any more significant figures, plug these all in your calculator and just write answers that you get on your calculator. Plug all these in and just put the whole answer, and then we'll come back and base them on significant figures. So just run those through on your calculator. $82.2367. Did you all get that? 787.16. Tell me what you have here. Okay, and then the last one. Good. All right. Now then, we're going to round these properly. And again, rounding's right above this. We have to do all this at the same time, basically, is what we're looking at. The rule for rounding is to look at the last significant figure, and then you find the next number to the right. If the next number to the right is 0, 1, 2, 3, 4, then you leave the last significant figure alone. If it is 5, 6, 7, 8, or 9, you're going to raise the last significant figure by 1. You don't ever round down. So let's look at how to round these properly. We have already decided this had 3, this had 2, this had 4. We need 2. There are my 2 significant digits. Does this 2 make that 2 go up? So what's my answer? 82. And that's my final answer. How many significant figures does 35.78 have? 4. 22. 2. My final answer then should have 2. There are my 2 significant figures. Does a 7 make an 8 go up? Yes. To a... So how do I write it? 790. Why? Because without putting a decimal there, is that 0 significant? No. So does this show 2 significant digits? Yes. Why wouldn't it just be 79? Because if I owed you $787.16 and I only gave you 79, would you be happy? No. But if I gave you 790, you would be. The point is you cannot change the magnitude of the number with significant figures. You have to keep the magnitude the same. Why don't I put a decimal? It would be 3 significant digits. If I needed 3 significant digits, then what would I have left it as? 787. Do you see that? All right, let's look at this one. How many significant figures here? Here? So my final answer should have 3. Does an 8 make a 9 go up? To a 10, carry the 1, that becomes 3, and then 2. Now, what do I have to do here to show 3 significant digits? I have to put a decimal. And some of you are saying, do you have to put the decimal? Yes, you have to put the decimal. Why? Because that's the only proper way to round this and show 3 significant digits. So you do have to put the decimal. The last one, how many significant digits are in 45.3? 3. 8.6? 2. And 954.83? 5. So my final answer should only have 2. Wow. How do I put that? I have to put it in scientific notation because there are my 2 significant digits. Does that 2 make the 0 go up? No. So I would round it to 5,000. But how many significant digits does 5,000 have? 1. So then that question way back here that I asked, how do you know when you have to put it in scientific notation? You're going to know because your significant figures require you to put it in scientific notation. And this is an example. So the answer is what? Very good. Yes or no?
Yes.
Go ahead.
When you get the 3 above your 10, do you start after the cap?
The 3 above the 10 starts from the decimal. So it's 1, 2, 3. Okay? Let's go back now to where we stopped a few minutes ago. And we have to write final answers. How many significant digits are here? 3. How many are here? 3. That means my final answer needs 3. Does a 1 make a 7 go up? No. So what's my final answer? 217. Yes or no? Okay. How many significant digits are in 8.4 times 10 to the third? 2. 5.223. 4. My final answer then should have 2. So how do I write that? Here are my 2. Does that 2 make the 0 go up? So what's my answer? Very good. That's exactly right. 1.0 times 10 to the 10th. Question. All right, let's look at the rounding. We've already basically said the rules. So why, you're probably wondering, why in the world is she teaching us something we learned in 4th grade? Well, if you had been taught it and learned it in 4th grade, I wouldn't have to teach it. Unfortunately, a lot of people can't round, though. The one example that I use a lot is literally this first example. This is the mass of sodium. Now, on that periodic table, it is not written exactly the same, but the periodic table that I have given you all, it is listed as 22.990. And I will tell you later in the semester to round this to the nearest hundredth. People come back to me and call it 23. Is that proper rounding if it's to the nearest hundredth? No. Rounding it to 4 significant digits is the same as rounding it to the nearest hundredth. Does this 0 make that 9 go up? What's the answer then? All right, run through these. I want you to do these right now. You guys seem to be on the ball, so run through those and round them properly. What do you have for 74.992? Good. 35.453. Good. This scenario, both of these two are the scenario that some of you remember as being a little bit more confusing. It's not, though, if you follow math rules. The 9 makes the 9 change to a 10, carry the 1, 10, carry the 1, 16.00. Yes or no on that? All right, what'd you get for this one then? Good. What'd you get here? Good job. Okay. Any questions on that? A question I would have if I were you is, do we have to do that every time? Yes, you do. Every problem that you solve has to be given in proper significant figures. So you're learning the math, then you have to put it in the right number of significant figures and round properly for the final answer. The benefit of chemistry, in my opinion, one of the benefits, is that what we do today, you will use all semester long. That, to me, is a nice thing because at least you don't just memorize it, take a test over, forget it, and move on. And then 10 years later have to come up and remember it. We will use it, and so you will remember it because of constant use. That's a good thing. So start using it now. Let's look at the other rule for significant figure calculations, and that is the rule for addition or subtraction. This is a totally different rule. Addition or subtraction is expressed to the same precision as the least precise measurement. In the first lecture, we talked about thermometers, and one of the thermometers was more precise than the others, meaning it had more calibration marks, which meant in the end our answer could have more places after the decimal. Many times, decimal place is the way we look at precision, but if it doesn't have any numbers behind the decimal place, then you still have to understand how an instrument was calibrated, which was also talked about on that first lecture. So let's do that first. Let's remind ourselves, if the number is written as such, and it's a measured number, again, I've left out units for speed today. If this is a measured number, how was this instrument calibrated that measured 254.0? How was it calibrated? Ones, and you guessed at tenths. So we are going to say that this is precise to the tenths. Now I realize the instrument itself was precise to the ones, but we're going to say it's precise to the tenths. How was this instrument calibrated? Tens, and you guessed at the ones. So is this the least precise? Yes. Now, do not get a calculator out. Solve this math without a calculator. Solve this problem without a calculator. Go ahead and solve all of these without a calculator. And then we'll come back and do significant digits. So we get 218.0, that's simply what we got doing the math. But if the precision has to be as precise as the least precise, then how do I write this answer? 218 without the 0. Are we counting significant figures here? Not at all. We're not counting. We are looking at precision. It's a different rule. It is a different rule. We're looking at precision. Question on that? Okay, tell me how this instrument was calibrated that measured 350. Hundreds. Good. This instrument was calibrated in hundreds. This is the jar that's calibrated in hundreds. This jar is calibrated every 100, 200, 300, 400, 500, 600 milliliters. So if I measure the volume of water in my jar, this is 400 and this is 500. And so looking at that basically up close the way I can see it, I would say that I have 440 milliliters of water left in my jar. Do I put a decimal at the end of that? No. No. Because do I have a line at 440? No. Where do I have a line? 400. Does that make sense? This is not a very precise instrument for measuring milliliters, is it? No, it's not at all a very precise instrument. But that's what that instrument would look like. So we say this is not significant. Is that correct? That 0 is not significant. That means that this is precise to the tens. This number, however, is precise to the tenths. It was calibrated how? Ones. So is this our least precise? And if it's to the tens, that means that this answer has to be rounded to the what? Not hundreds, but tens. We have to round this to the same precision. So does the 5 make the 1 go up? So what's my answer? 4, 2, 0. Do I put a decimal? No. Now, some of you right now want to just say, that is stupid. Because you're thinking 420 compared to 415.3, that's a big difference. It is, I agree. It is a huge difference. It could be a huge, huge difference. So how is this correct? Well, it's correct because the rule says you have to go with the least precise. But I'm going to use this as a method of helping you understand why it's important to learn how to measure things properly. How many of us have measured with an instrument and it's been on the line and we just wrote whatever and just put a 0 at the end without a decimal? So like say this example, it was, let's pretend that the same instrument measured both of those. Let's pretend it's meters, okay? Let's just pretend this is meters. And the same instrument measured meters, 350 meters, and it measured 65.3 meters. But when we were measuring the 350 meters, it was exactly on the 50 line. Now, if it's the same instrument that measured this, do I have ones marked off on my instrument? Yes, if it was, and I'm telling you, pretend it was the same instrument. So this instrument had ones marked off, right? But let's pretend I used the same instrument, and it had ones marked off, but it was exactly on the 350 line. So I wrote it down as 350 without a decimal and without putting another 0 because it's on the line, right? How many of us have thought stuff like that? It doesn't matter. What's the big deal? It doesn't matter, does it? Now, the question is, if I had truly used the same instrument for both of these, and this is what I end up with because I thought it didn't matter if I put 0.0, now do you see it could matter? It could make a big difference. Real world, it could make a big difference. Let's just pretend again. I told you that if you went 420 feet from the edge of Snell Hall, and I told you to go east or west, whatever, at a certain direction, and let's say that I told you to go 420 feet and dig a hole and you'd find a 5-pound piece of gold. But really, it should have been 415.3. Would that make a difference? Yeah, it would make a difference. So use your instruments properly. On your first exam, you will have questions where I have instruments and you have to measure something on those pictures correctly, meaning you have to understand significant figures. You have to understand if it's calibrated in ones, you guess at tenths. If it's calibrated in hundreds, you guess at tens. If it's calibrated in tens, you guess at, okay. All right. Last problem is honestly the easiest one. Which one of these is the least precise? 25.0 is the least precise. It's precise to the tenths. There's our tenths place. Does a 4 make a 6 go up? What's my final answer? Good. Yes or no? Okay. All right, the next part of this is all about conversion factors. And this, we're going to spend basically 3 class periods dealing with dimensional analysis and conversion factors, and this is the start of it. Conversion factors are numbers and their units that equal other numbers in different units. All of these are conversion factors. Most of these you know, or I'm hoping you know. Hopefully you knew 5,280 feet in a mile, 2 pints in a quart, 16 ounces in a pound, and that's dry weight, 2 cups in a pint, 3 feet in a yard, 12 inches in a foot. Hopefully you knew those things before you came in. Those are all conversion factors. If you don't know them, learn them. So of these, it says memorize these. So this is like the second thing for this class you have to memorize. What was the first thing you should be memorizing? Symbols and elements. Good. This is the second thing you should be memorizing. It's these conversion factors. This says that these in this column are exact conversion factors. That means what? Anybody want to tell me what that means when it says they're exact? No significant figures. That's exactly right. We don't worry about significant figures if it's exact. We don't worry about significant figures. If it is not exact, then we do look at significant figures. And so these are not exact. That means we will use significant figures for these. What does that mean? Well, the 1 means exactly 1. You don't worry about significant figures for 1. What you use significant figures for are the other number. So how many significant figures does 0.621 have? 3. 3 significant figures. 2.20, 3. 454. Come on. 3. 946. So all of those have 3. I've said memorize them. Let's get that down to the nitty-gritty. As I just said, on this side, most of these I thought you already knew. If you don't know them, then yes, you have to learn them. This one is definitely new for most of you. 1 inch is 2.54 centimeters, and that is exact. All of these you need to know. This may be new. This may also be new. The 1 milliliter equals 1 centimeter cubed, which is the same as a cc. That possibly is new as well. Okay? On this side, what we are looking at are several duplicates. There are several things here that are the same thing, basically. So I'm going to narrow this down for you to make it really clear what you do and do not have to know. I would learn 946 milliliters in a quart. I would definitely learn that one. However, if you already know 8 fluid ounces equals 1 cup, then this one would also work for you to do the same calculation. You follow what I'm saying? Because this is fluid ounces, this is milliliters, this is cups. Could cups go to pints, pints go to quarts? So you could do the same thing. But if you want me to give you a limit, then learn this one and don't worry about this one. Or learn one or the other. You don't have to learn both necessarily if you don't want to. Of these 2 or 3, I'm going to learn this one because I've learned it a long time ago. Many of you, though, already know 2.20 pounds in a kilogram. And that's fine. If you know that one already, then use it. Either one of those is fine. You could also learn 28.4 grams is an ounce because you know 16 ounces is a pound, and it's going to give you the same thing. Again, if you're wanting me to limit what you have to memorize, I would memorize the middle one. Nursing folks love to memorize this one, though, so it's up to you. All right? Of this group, what do you have to learn? Well, on one sheet, I actually took all those out, and I'm going to take them out here. This is what you learn. I'm going to teach you how to do metric conversions a way that you may not have ever done before. I have taught metric conversions many different ways, but I have found out that this is the best way, and students seem to get it better this way. Most all of you, if not every one of you, have been taught metric conversions in every science class since probably 6th grade or before. Unfortunately, though, if I were to give you a sheet of metric conversions, not every one of you could get all those correct. And so I found out that you're not really learning them. You're memorizing some things, but you're not really learning the process because you forget which way to go. And so I'm going to teach you how to do metric conversions, but I'm teaching you using the method of dimensional analysis. Dimensional analysis is what's talked about on the next page, and it's where we use conversion factors, which is what all this is about, to get us from one unit that we don't want to be in to another unit that we want to be in. Okay? That's what dimensional analysis is. Many of you have done this before. Some of you may have called it factor label method. I'm going to teach you how to do metric conversions using that method. But in order to do that, you have to memorize these words. I'm not asking you to memorize numbers right now. I'm saying memorize these words. Now, what do I mean by that? When I say memorize them, literally, this is what you're going to say back to me. Kilo, hecto, deca, base, deci, centi, milli, space, space, micro, space, space, nano. Just like that. Have that in your head all the time. Kilo, hecto, deca, base, deci, centi, milli, space, space, nano, or space, space, micro, space, space, nano. I messed it up. Okay? Have that in your head. Why? Why do I want to have that in my head? Because the metric system is so simple if you'll just memorize those prefixes. Because the entire metric system is based on powers of 10. That means if you memorize this ladder of prefixes, that means that 10 millis are in 1 centi. 10 centi are in 1 deci. 10 deci are in 1 base. And what is base? Kilo or base is meter, liter, gram, or whatever. 10 bases are in 1 deca. And the way I use the metric prefixes is I always look at how many small things are in one bigger thing. So as long as I memorize kilo, hecto, deca, base, deci, centi, milli, space, space, micro, space, space, nano, and I know these are my big prefixes, these are my little prefixes, then I can figure out any metric conversion without having to memorize a lot of them. I just know this, and then I can figure them all out. Most of you already know, coming into here, 1,000 meters in a kilometer. But what if I ask you how many centimeters are in a kilometer? You probably can't tell me without figuring out something else. You might say, well, there's 100 centimeters in a meter, there's 1,000 meters in a kilometer. You have to do those steps. The way I'm going to show you, you can make a conversion factor with any of these. So let's just do the one I just said. Kilometer and centimeter. What is the relationship between kilometer and centimeter? Well, first you have to decide who's bigger. Kilo is bigger. So whoever is bigger gets 1 in my method. Whoever is bigger gets 1. Whoever is smaller gets 10 and a power. And the power, or the exponent, is the number of spaces you move. So here we are at centi, and we're going up 1, 2, 3, 4, 5. That means there are 10 to the 5th centimeters in 1 kilometer. Notice what I've done. I have a lot of little bitty things in one really big thing. Do you all remember the metric conversion charts that you would see in every textbook? And it would have all these prefix names, and then it would have like 1 and then 10 100, 1,000, and then down at the bottom it would have 1, 0.1, 0.01, 0.00, and you're like, what does that mean? I hate that chart. I mean, it doesn't even make sense. Because my brain and most of your brains, we don't think of 1/1000th. 1/1000th of a meter is a millimeter, but I don't think that way. What I think is 1,000 millimeters equals 1 meter. Think about how our whole world is. It's how many little things are in a big thing, right? We don't say, give me 1/12 of a dozen eggs for breakfast, Mom. Do you do that? No, you say, I want 1 egg. Because you know it's part of the dozen, but we don't talk about it in a big sense. We talk about it in little things equaling 1 big thing. This is my method. And by doing it this way, none of my exponents are ever negative. Because what am I always looking at? How many small things are in 1 big thing, which is how my brain works. So let's do another one that you're not familiar with. Deca is this DA. I want to know decagrams and micrograms. Now, micro is this cursive U. Some of you want to know, what do these spaces mean? And the answer is, I don't know. It doesn't matter. We know there's something there. It just doesn't have a name. Or it might have a name. I don't know what the name is. It doesn't matter. Meaning there's 10 to the third micros in 1 milli. That's what's important, to know that there is a space here, so you have to count it. And doing these metric conversions, if you can play a board game, and when you're playing a board game, do you count where you're standing, your man standing? No, you count the next one, right? It's exactly the same way. So who's bigger, Deca or micro? Deca is bigger, that means it gets 1. Micro is smaller, so we're down here. We don't count the space where we're standing, but we go 1, 2, 3, 4, 5, 6, 7. That means what? 10 to the 7th micrograms in 1 decagram. Is that making sense? All right, let's do one more. I want to know the relationship between milliliters, milliliters, and hectoliters. Milliliters and hectoliters. Figure that conversion out. Milliliters and hectoliters. Who's bigger? Hectoliters bigger? So tell me the relationship. What is it? 10 to the 5th milliliters in 1 hectoliter. Is that making sense? All right, then let's use it. So starting off, the first part of this is simply kind of what we've already done. I'm not going to go into that anymore. We've already talked about it. This is just a brief description of what dimensional analysis is. Again, I've already mentioned it. We are going to start practicing dimensional analysis just to show you what it looks like. I want to show you with something you already know the answer to. How many inches is 5 feet? 60. So that's 60. You know the answer is 60. I'm teaching you the method of dimensional analysis, though. And so we're going to use dimensional analysis to do all these metric conversions, and I'm going to show you with something you already know the answer to so that you see the setup. The setup for dimensional analysis is you write the given, and I do it really a shorthand method. Some of you may have learned it like this. It's the same thing. I just cheat and don't cheat, but I cut corners in a sense and don't draw the lines, basically. So 5 feet is my given. If you want to make a note what that is, that's the given. And then we're going to use conversion factors. So this is my given, and then we're going to use conversion factors. What is the conversion factor that gets me from feet to inches? Say it again. 12 inches equals 1 foot. Where is 12 inches going to go if I want to get out of feet? 12 inches is going to go on top. Where's foot go? On bottom. Why? So feet can cancel. Dimensional analysis is converting a unit into another unit using two numbers that equal each other, but they have different units. 12 does not equal 1, does it? But do 12 inches equal 1 foot? It's the units. This is sometimes called unit analysis. Question on what I did here. Again, if you learned it this way, you may have seen it set up like this. Feet cancel, same thing. Mathematically, once you get your units into what you want to be in, you multiply the top, divide by the bottom. Now, in our case, it's 1 on the bottom, so we don't worry about it. 5 times 12 is 60. So you knew the answer. This is the method using dimensional analysis. But we're not done. We have to use significant figures. So we go back to our original numbers. Significant figures here. How many? 2. Does 12 inches equal a foot count for significant figures? Why not? It's exact. Good job. So my final answer has 2 significant digits. How do I write this? I have to put a decimal, inches, just like that. That means over here, did I write it correctly? No. It needs to be the decimal. Yes or no? Okay. How many of you have never done anything like this before? Has anybody in here never done it? A couple of you? Okay, and that's okay. What's great is that the majority of you have. That's the good thing, okay? I want to stress this comment right here. I am looking for success on the process as well as correct answers. I am adamant about you learning dimensional analysis. I know how important it is for you to learn dimensional analysis. 90% of the students that take Chemistry 109 are nursing majors. You will use this. Those of you that are not nursing majors could still use it. I use this process to solve problems in my kitchen. It's scratched in my cookbooks, different conversions. I use it at the barn. I use dimensional analysis. It's something that can be used. Don't be like my daughter who calls it demon analysis, okay? I promise you, it's a useful thing. She finally has confessed. It is useful. She agrees now. But it took her about 2 years. So don't wait that long. It will be good if you'll learn it. I don't want you jotting down answers for all of these out of your memory. I want you using the method. So I'm going to teach you again and show you the method on these problems using dimensional analysis. Before we do that, though, let's go find the conversion factors. I want us to find the first 4. Go over here and find the first 4 conversion factors. So what's the relationship between milligram and nanogram? All I want you to do right now is just figure out the conversion factor knowing your prefixes. So go through and figure out the conversion factors. If you're struggling, who's bigger, milligrams or nanograms? Milligrams is bigger, so it's 1 milli. Here's nano on the bottom. 1, 2, 3, 4, 5, 6. That means 10 to the 6th nanograms in 1 milligram. Who's bigger, centi or micro? Centi, so 1 centimeter. 1, 2, 3, 4. That's 10 to the 4th micrometers. Are you getting these? Did you have these? Who's bigger, decagrams or grams? Deca is bigger. How many spaces is it? Just 1. That means 10. 10 grams in 1 decagram. 10 to the 1 is the same as 10. By the way, if you have forgotten what 10 to a power really means, it simply means 1 and that number of zeros. So if it's 10 to the 1, that means 1 and 1 zero, which is 10. If it's 10 to the 2, that means 1 and 2 zeros, which is 100. Okay? Who's bigger, kilo or milli? Kilo. And this is then 10 to the what? 6th. Do these make sense? Anybody question these? All right, then let's do the dimensional analysis. We start off with our given, 8.45 milligrams. Who goes on top? Or who goes on bottom? Let's do bottom first. Who goes on bottom? Milligrams. Now, what number goes with milligrams? 1. So 1 milligram goes on bottom. What goes on top? 10 to the 6th nanograms. Why did I put milligrams on bottom? So it would cancel out. Now, guys, you don't have to do this on your calculator. Simply write exactly what it says. 8.45 times 10 to the 6th nanograms. Isn't that correct scientific notation? But I want to put it in my calculator. I want to make sure. All right, let me teach you how to do that. Find in your calculator or find on your calculator, find the caret key if you have this TI-30X2S calculator, or find the Y to the X key. Find either one of them. When you plug this in your calculator, because it is not truly scientific notation, you will plug this in as an exponent. So you're going to plug in 10, then hit the caret key 6. So just try this. Put in 8.45 times 10, and then Y to the X or caret key 6 equals. And you should get on your calculator 8, 4, 5, and then 4 zeros. Do you see that? Okay. When do you use EE? When it's already in scientific notation. That's when you use EE. All right, let's do the next one. The given, 36,500 micrometers. You've already calculated the conversion factor, so what goes on top? 1 centimeter goes on top. What goes on bottom? 10 to the 4th micrometer. What unit cancels? Micrometer cancels. If you know math, which I hope you do, you could just simply do this one in your head because you know what 10 to the 4th does to that number. But if you don't know, then plug it in your calculator. 36500 divided by 10, then hit the Y to the X or the caret key, 4. Tell me what you get. 3.65 centimeter. Yes or no? Okay. Before we go any further, there's something I haven't mentioned, and that is significant figures. So let's go back. Should significant figures change when you convert into or out of scientific notation? No. Why not? Because metric conversions are exact. So they should not change the significant figures. Let's make sure they didn't. Let's check that. How many do we have here? 3. This is exact, so it doesn't count. How many do we have here? 3. How many do we have here? 3. How many do we have here? 3. Okay? Let's keep going and do that from this point forward then. So 9580 grams is my given. You have the conversion factor figured out over here. What goes on bottom? 10 grams. What goes on top? 1 decagram. Guys, do that in your head. What's the answer? 958 decagrams. Just get rid of those zeros. 958 decagrams. Significant figures are both what? 3. Good. Now, I'm going to let you do the next one. You set it up and do it, and then I'll put the answer and see if you get it right. What goes on top? What goes on bottom? What cancels? Kilometers cancels, and what's my final answer? I could write it two different ways. 4.5 times 10 to the second millimeters, or if I write it as 450, do I put a decimal? No. Question. Question on that. Okay, I'm going to leave these two for you to do later. I think there's some value in you doing these later. So I'm going to let you practice those. The answers are already on Blackboard. So you practice those. And let's flip it. And just for the fun of it, you do this first one up here. Whoop, I gave you the wrong sheet. I gave you the one I've already done, didn't I? You do this one. What is the conversion between milli and hecto? Say it one more time. 10 to the 7? 5th? What am I hearing? I'm not hearing. 10 to the 5th. 10 to the 5th. So where does 10 to the 5th milligrams go? On bottom. And what goes on top? 1 hectogram. So milligrams cancel, yes? So what's my answer? 1.8 hectograms. Question?
Wait, I plugged into the calculator and got 1.85, but and then you looked at significant figures, right?
No.
It's supposed to be 1.8.
You should not have gotten 1.85. Clear it all out and do it again. 1.8 EE5 divided by 10 y to the x5. But don't plug something that simple in your calculator.
Well, just double checking.
No, don't do that. Double check with your brain. Look, 10 to the 5th cancels out 10 to the 5th.
I like to make sure I'm right.
No, you are right. Your brain knows. Knows. Guys, that reminds me of something that some of you all did. I send 2 emails at least that say we don't have class Monday night. And then you send me back an email and say, now, so we don't have class Monday. And when you did that, I wasn't trying to be rude, but I sent you back an email and I said, I'm not trying to be rude, but if you will please read the announcements in the emails, your answer will be found. Guys, let me stress to you all, if you want to be a nurse, you have to think, and whatever the doctor says, you have to do it. You can't say, now, are you sure I'm supposed to do CPR? Are you sure? But now that wasn't written in the protocol. They're dead, people. People's lives depend on you. Please be proactive. If it's written, that's what it means. You don't have to ask me again. Now, with that said, there is something I said to my morning class that I want to stress with you all. I want you to ask me questions. I might say to you, I'm not trying to be rude, go read. I may say that to you. But in class, I want you to talk to me. I have a philosophy. It is much better to ask questions and look dumb than not ask questions and be dumb. I want you to talk to me. I know that I get intense. I know I get like that. I know I do, okay? I know I'm loud. And I get louder and louder the more excited I get. I know that. I'm not yelling at you, I promise. If I yelled, you would know. Because I can yell. Okay? I'm not yelling at you. But I want you to talk to me. But I also expect you to use your noggins. You've got good ones. Trust yourself, okay? Try it. Some of you don't get to try things, so you don't know how because you're scared of failure. Try it, okay? Try it. Now, with all that said, let's try this question about Lee's mass. I'm going to skip this one. It's another metric conversion. You can do it on your own. This is a real dimensional analysis problem. So what is the given? 187.2 pounds. That is my given. 187.2 pounds is the given. Now there's more than 2 ways to do this problem, but there's 2 ways specifically that I want to talk about how to do this problem. The first one is the nursing way, and that's the short way to do it. What is the quick conversion factor that would help us solve this problem? 2.20 pounds equals 1 kilogram. So where's 1 kilogram going to go? So 1 kilogram goes on top. What goes on bottom? 2.20 pounds. Pounds cancel. Run your numbers. What do you get on your calculator? 85.09. Do you get that on your calculator? Then we have to say, what's the final answer? So we have to go back and look at significant digits. How many significant digits are here? 4. How many does this have? Does it count? Yes, it's on the not exact side. So how many should we have in our final answer? So this had 4, this had 3. We need 3. So what's my final answer? Kilograms. Unit. You have to put the unit. There's another way to do the problem, the way I would have done the problem. 187.2 pounds. Now, what do you think I'm going to convert into? I will convert it into grams first, then I'll go to kilograms, just because that's what's in my head for years. What is that conversion factor? 1 pound is what? Look it up. 1 pound equals 454 grams. 1 pound is 454 grams. And then what will I do? Grams to kilograms. What is that relation? 10 to the what? 10 to the third who? So where's that going to go? So 10 to the third grams on bottom. What goes on top? 1 kilogram. Grams cancel. Run your numbers. Multiply the top, divide by the bottom. You do not need to stop and start. You simply multiply the top, divide by the bottom. And don't worry about the 1. So just take 187.2 times 454 divided by 10 y to the x3, or 1,000. Tell me what you get on your calculator. $84.9888. Yes or no? How many significant digits do I have here? How many here? How many here? Does it count? It does not count. I don't worry about it. So my final answer should have 3. What is my final answer? 85.0 kilograms. Good. Now your question is, well, which is the right answer? They're both the right answer. It just depended upon which conversion factor you used.
Why did the third grams not count?
Because it's exact. All metric conversion factors are exact. Ones don't count at all. The ones don't count, period, because it is 454 grams, which is a rounded number, in exactly 1 pound. So the 1 pound is exact, but the 454 is not. It's a good question.
Which one on a test are you not? You're not going to do something that mean? Like,
No, I could. You will just know the right answer because of the choices. It's multiple choice. Now, on your homework is really the question. On your homework, there's no, if it doesn't tell you which conversion factor to use, you could use either one, so how is it going to know that it's correct? Well, the beauty is there's a built-in little fudge factor there, so it will give you, on a problem where there's more than one conversion factor, it knows that, and it will take either one. Other questions on that problem? All metric conversions are exact. All metric conversions are exact. Now, I'm saying my answer differently than what you expected me to say. You're thinking that all of these are metric conversions, I think. No, these are metric conversions. This is what I'm calling metric conversions because it's within the metric system. These are English metric or standard metric conversions or general conversions. These may or may not be exact. It's a wording issue, how you word it versus how I word it. I'm referring to just these when I'm calling them metric conversions. See, this is really not a metric conversion. This is standard to standard. This is a metric conversion to standard, but not just a metric within the metric, okay? These are all exact. All of these are exact. These are the only ones that use conversion, or use significant figures, rather. Sometimes the conversion factor is within the problem. I'm going to skip this one. I'll come back to it. This is the one I'm talking about. The metric, or the, I said metric to myself there. The conversion factor is within the problem here. What is the conversion factor that's within this problem? You'll have to use more, but there is one here. What is it? Say it again. I think I heard it over there. Say it louder. No, I'm saying something that's written. Yes, you're going to need 60 minutes in an hour. I'm saying what is written in the problem that will be used as a conversion factor. Say it one more time. I'm hearing part of it. Say it one more time. Who said that? Miles per hour. Guys, what's in the problem that's a conversion factor? What does this mean? 35. Tell me exactly what it means. In 1 hour. Is that a conversion factor? Yes. That means this is my what for this problem? Let me say this. For a dimensional analysis problem, you are either the given, you are the conversion factor, or you're the answer. That's your three choices. You have to be one of those things. So if 35 miles per hour is a conversion factor, what is 13 kilometers? It's the given. So the given is 13 kilometers. Sometime in the problem, we are going to use this. Do you think that we will use this next, or will it be later? Later. So what do we use next? We have to somehow get kilometers into something to be able to use this. We can go kilometers to miles if you choose to memorize that one. That makes it fast. We'll do it that way first, and then I'll show you the longer way. If I use the conversion that's on your sheet for miles and kilometers, tell me what to put on top. 0.621 miles goes on top. What goes on bottom? 1 kilometer. What cancels? Kilometers cancel. Now I am in miles. So now 35 miles goes on the bottom. Good. So 35 miles goes on the bottom. What goes on top? 1 hour. And now I'm ready to go to minutes. So what goes on top? 60 minutes. What goes on bottom? 1 hour. Hours cancel. Multiply the top, divide by the bottom. Tell me what you get. $13. Good. All right. I'm just going to stop there. It won't matter past that. Did anybody not get that? Clear it all out, plug it in again. Did you get it? Okay. Significant figures. How many does 13.0 have? 3.621, 3, 35, 2. Now, I have not written down anywhere 60 minutes in an hour whether it's exact or not, but you should know the answer to that. It's exact. That's exact. That means how many significant figures should I have in my final answer? 2, which means my final answer is 14 minutes. 14 minutes. Yes or no? That is the shorter way to do the problem. The longer way to do the problem, I'm going to show you below. Because I don't memorize the .621 miles in a kilometer. That's not something I put in my memory bank. Instead, what could I use? What is an standard to metric unit or conversion for length that I could have used? Say it. Well, I could do I'm going to need that one, 5,280 feet in a mile. I'll definitely need that. But that's still in the standard system, like inches and feet, miles. That's what I have to use. Think about what she just said. 1 inch is 2.54 centimeters. Is that a metric unit converted to a standard unit? We used to call that the English system, but actually in England they don't use it. They use the metric system. So it's called the standard system. I'm going to use that one. Now, I want you to think about the steps that are going to be involved in that. It's going to be long. So let's make a little roadmap out about it. We start with kilometers. And over here, we're going to end up with, for my final answer, what am I trying to find? Minutes. So from kilometers, where am I going to go? If I'm going to use what she said, what am I going to do? Go from kilometers to centimeters, then centimeters to inches, that's the one she said, then inches to feet, feet to miles, then miles to hour using speed, with me? And then hours to minutes. Does that make it longer? Definitely makes it longer, but it's still doable. So let's do it. What you're given? Kilometers. Guys, you might want to write this down. You might see one like this somewhere. Put it at the top of the page or something. Tell me what to do. What's my next step? Kilometers is going to go on bottom. What do I want to be in? Centimeters. So where do I have to go? Kilo, hecto, deca, base, deci, centi, milli, space, base, micro, space, base, nano. Go over there. What is it? Who? 10 to the 5th centimeters is equal to 1 kilometer. Are you all following where I'm getting that? Okay. Kilometers cancel. Now I'm in centimeter. Now I can get into that standard system. Tell me. 2.54 centimeters goes where? Bottom. 2.54 centimeters goes on bottom. What goes on top? 1 inch. Centimeters cancel. Where is 1 foot going to go? 1 foot's going to go on top. What goes on bottom? 12 inches. Inches cancel. Now what? 5,280 feet on the bottom. 1 mile on top. Feet cancel. Now I'm ready for speed. What goes on top? 1 hour goes on top. What goes on bottom? 35 miles. Can conversion factors be flipped? I've done it, but I haven't said they can be. But yes, they can be. And that's what we did there. And then last is 60 minutes in 1 hour. I want you to plug this one in your calculator. That's why I had you do this, because you have to do what I'm telling you to do. Don't use parentheses. Multiply the top, divide by the bottom. Do not multiply the top, then multiply the bottom, and then take the top divided by the bottom. Simply multiply and divide, and if you have 5 numbers on the bottom, how many times are you going to divide? If you have 5 numbers on the bottom, how many times are you going to divide? 5 times. See if you get the right answer. What do you get on your calculator? 13.8477. Do you get that? Did anybody not get that? How would I literally plug this in my calculator? I would take 13 times 10 y to the x5 divided by 2.54 divided by 12 divided by 5,280 divided by 35 times 60. I do it in order. I do it in order. Do not use parentheses. Just simply plug it in like that. Is this the final answer? No. We have to go back and figure out significant digits. How many are here? 3. Doesn't count. Doesn't count. Look where it is. On your list, where is it? It's exact. It doesn't count. What about this one? It's exact. It's exact. It counts for 2. Exact. Okay? So do we end up with the same answer? Yes, we do end up with the same answer because of the limiting 2 there. Does that make sense? All right, the problem above this is also a long problem, not as long as that one, but it is several steps. In order to do this, you need to decide where you are and where you're going. Where are you? You're in 1 pint. And you're going to liters. What quantity are we talking about here? Are we talking about length? What are we talking about? Mass? Volume. We're talking about volume. We're talking about volume. So we are looking at pints and trying to get into liters. If I were to draw the road map, let's see what that would look like. We're in pints. We're trying to go to liters. Tell me what you think you would do next. Pints to what? Quarts. Quarts to, look at your sheet. What would you do? You're right. Milliliters. And then milliliters to liters. I'm going to be quiet and let you try this one. I want you to try it. You have the conversion factors in front of you. I want you to try it. For those of you that did not print out notes prior to class, please print them out. It's hard to stay with us when you don't have the notes. They're there for you, so please print them out. If you don't know how to do that, don't know where to go, Ask me or watch the first video. It'll tell you. What goes on top? 1 quart. What goes on bottom? 2 pints. Pints cancel. Now what? 1 quart on bottom. Quarts cancel. 1 liter on top and 10 to the third milliliters on bottom. Milliliters cancel. Run our numbers. And what do you get? You get 0.473 on your calculator. Yes or no? Remember, quit double fingering your calculator. Some of you just keep doing it. 1 finger. Significant digits, what counts? Yes, it does. It counts. The given counts unless it says it's exact. And it doesn't say it's exact. So it counts as 2. This is exact, so it doesn't count. 3. No, this is not exact, so that's 3. This is exact. So what's the fewest? So what's my final answer? 0.47 liters. Yes or no? Making a little sense? In this problem and in this problem at the bottom, there are conversion factors that are within the words. Try these, work on them, see what you can come up with on these, okay? Now, typically speaking, we will not be done until 6:50. Every night. Tonight, I must have talked faster tonight than I did this morning. I don't know, but I'm done. I did more problems with you all than I did the other class. But I want you to talk to me if you need any help with where to find the notes on Blackboard, whatever. Talk to me. If you have a math question as far as should you take the course, let me know. And I will see you on Wednesday. Or Monday. Today is Wednesday. Sorry, Monday.